Here we see what the FPGA development flow looks like. So in Lesson 2, we'll talk about evaluating your system requirements first, and then you select the appropriate architecture. Next, you configure your hardware, and you create a LabVIEW project. So here, we are evaluating our system requirements. So this is an overview slide, and we'll talk about more on each of these in the coming slides. So first of all, you need to determine, do you need FPGA? Do you need the reconfigurability and the speeds that are offered by FPGA? If yes, then the next thing you need to do is to select the RIO architecture. So you can either do an FPGA for Windows or FPGA for real-time. Once you've selected that, then you have to figure out what's the platform that I want to run on. So do I want to use a PCI or PXI, or am I going to use a CompactRIO? So after you've selected your platform, then you might want to think about other considerations when you're selecting your hardware. For example, you might want to look at the FPGA size, what kind of I/O do you need, and things like that. In this course, the exercises will be done on two different platforms. So one will be for FPGA for Windows. You'll be using a PCI R-Series card. And if you're doing the real-time exercises, then we'll be using the CompactRIO platform. In this slide, we see two FPGA system architectures. One is LabVIEW FPGA architecture on Windows, and another is LabVIEW FPGA architecture with LabVIEW real-time. In the next slides, we'll dive more into this. For now, I just want to talk about the differences between whether you'd want to use something on Windows or if you would want to move to something on real-time. The benefits of running something on a real-time operating system is that it's going to be more reliable, and also it's going to be more deterministic, which means it's going to have less jitter. And you're going to be able to more reliably predict how fast it's going to take something to run each given time. For more information about real-time, you can go to ni.com/realtime, or you can take the LabVIEW real-time course. So here we see what the FPGA with Windows looks like. So if we're taking a look at the slide, you see that, first of all, you have a computer that's running the Windows operating system. So this could either be a PC or it could be a PXI system, but regardless, it's running a Windows OS. So notice that you've got your FPGA inside the system. So you might have a PXI or PCI FPGA board that's inside your computer. And this has the FPGA on it, and this is where your FPGA VI logic is going to run on. So notice that there's a communication piece as well. So the FPGA VI is going to be able to communicate with a host VI that is running on your Windows computer. Here we see what an FPGA with real-time system looks like. So if we look on the right, you'll see that there is a LabVIEW real-time system, okay? And the LabVIEW real-time system is running a real-time operating system. So this piece of hardware could either be a C-RIO, a single board RIO. It could also be a R-Series that's running in a PXI chassis that is running real-time OS. So if we take a look at that, again, we have an FPGA piece, and this is the FPGA hardware. Again, this is going to be running the logic that's defined in our FPGA VI. That FPGA VI is going to be able to communicate over the bus to a host VI that is running on your real-time operating system. And then another piece we have here is the Windows system. So if you want a user interface for your application, then you'll be developing a VI on a Windows machine, and that Windows VI is going to be communicating with your real-time operating system through network communication. So here we see LabVIEW programming and CompactRIO. So let's take what we just talked about in that last slide, where we have a LabVIEW FPGA system running with real-time, and let's see how that maps out to our hardware. So first, let's start with the FPGA. So if we look on the right, we see a CompactRIO hardware, and we see some I/O modules. So behind the I/O modules, it's connected to a backplane of that CompactRIO, and on that backplane, that is where the FPGA exists. So the FPGA is going to be able to communicate with our real-time operating system. So in the case of CompactRIO, the real-time operating system is executing on the CompactRIO controller. So the other piece with Windows, notice that we've got a laptop on the left, and on the laptop we've got a Windows operating system running, and we have a VI that's running on Windows, and this is going to provide our user interface. This Windows VI is able to communicate with our real-time processor through the network. Now you can describe the LabVIEW FPGA architecture on Windows and LabVIEW FPGA architecture with LabVIEW real-time. Next, we will describe common reconfigurable I/O platforms.